Good morning, good afternoon, good evening. Thank you for joining us. I'm Alicia Main, the W.J. Van Dusen Professor of Innovation and Entrepreneurship at the Beatty School of Business at Simon Fraser University. I'm also the Academic Director of the Invention to Innovation, or I2I program, and the MyTax I2I program, and Special Advisor on Innovation to the VP Research and International here at SFU. Before we begin, I'd like to acknowledge that I'm speaking to you today from the unceded traditional territories of the Musqueam, Squamish, and Tsleil-Waututh peoples. It is a privilege to live and work in such a beautiful place. I'd also like to send our thoughts and support to all the people in BC who are dealing with the after effects of the terrible floods last week. We are excited today to talk about Canada's potential as a world leader in clean energy innovation. Most importantly, how are we going to ensure that Canadian green energy breakthroughs take their place on the world stage? The race for climate solutions is on. The need to accelerate and translate the cutting-edge research from Canadian labs has never been greater. Many of the solutions we need to meet our 2030 greenhouse gas emission targets, such as carbon capture and storage, fuel cell technologies, already reside within Canadian ventures, some even right here in BC. For example, Carbon Engineering is an ambitious direct air carbon capture company which spun out of the University of Calgary in 2009 out of the research lab of Professor David Keith. They set up research facilities and a pilot plant in Squamish in 2015, further developed and tested their process technology and business model, and are now raising financing to build a $1 billion commercial scale carbon capture and storage operation in Texas. Svante is another ambitious Canadian carbon capture and storage company, founded in 2007 in Burnaby, BC. Svante captures CO2 directly from industrial sources at less than half the capital costs of existing solutions, with strategic partners including several multinational petrochemical companies such as Suncor, BP, and Chevron. And with recent investment from the Canadian Strategic Invention Fund, Svante is also well positioned to contribute to the clean energy transition. Ionomer, from whom we have a speaker here today, also has huge potential to lead in the clean energy transition. With world-leading solutions in green hydrogen production, energy storage, and conversion of CO2 to synthetic fuels. Founded in 2015 out of the research lab of Professor Stephen Holdcroft in the chemistry department at Simon Fraser University, Ionomer successfully scaled up their breakthrough electrolysis membrane and have been winning international awards and contracts for their commercial scale amnion and pemion products. These technologies are ready now to be enabled within existing climate policies and at commercial scale in some applications. They will help bring us towards our 2030 climate targets. However, according to the International Energy Agency report Net Zero by 2050, released in May of 2021, half of the technologies needed to meet our 2050 zero emission targets, such as economically viable green hydrogen production, are still undeveloped or nascent in university and government research labs. We need to start now to build our capacities in these areas. For example, here at Simon Fraser University, Professor Sami Khan's Engineering Interface for Sustainable Energy Lab is conducting research in overcoming challenges in transporting hydrogen within current pipeline infrastructure and in enhancing carbon capture, conversion, and storage. The Holdcroft Lab at Simon Fraser University continues to lead internationally in advanced materials to help harness the power of clean hydrogen and to reclaim carbon. From that Holdcroft Chemistry Lab came Ionomer Innovations, Inc., which was purposely supported across the entire SFU Innovates ecosystem. First, the principal investigator, Professor Stephen Holdcroft, was supported in preparing an NSERC I2I translational grant, which was hugely important to them. Then the founding CEO, Ben Britton, developed commercialization strategy and entrepreneurial mindset in SFU's Beatty School of Business I2I program. Materials fabrication and testing facilities were accessed at 4D Labs, a core facility at SFU that allows scientists, academics, and industry to de-risk their technology, patenting support through the Technology Licensing Office, and mentoring team development and marketing through Venture Connection and Venture Labs. Science innovators, specifically those commercializing the engineering and deep tech needed to address challenges such as climate change, sustainable energy, and water and food security, face high uncertainty before creating and capturing value. It takes an average of 10 to 15 years and tens of millions of dollars of commercialization investment to translate a breakthrough invention into revenue generating products. We therefore need to adapt innovation policy to support more complicated, slower growing concepts that could be an essential part of our climate solutions while creating a thriving Canadian clean tech economy. And there's been several discussions around that, including a panel discussion yesterday on connecting and building the Canadian science innovation ecosystem. Canada's universities and our leading researchers can be a big part of the clean energy solution. We need to equip our researchers with the education, translational support, and de-risking support to enable our leading inventors to develop clean energy ventures, which are built for scale. They're built for scale purposefully from very early stages in the research labs. With such innovation supporting policies, Canada can simultaneously be a powerful originator of value creating companies with high quality jobs and unique products and processes, which can be exported around the world. We also need to choose areas of focus and build purposeful medium and long-term strategy implemented through consistent innovation policy and climate policy. Good science policy can support key actors at each stage of the clean energy innovation process, helping bring breakthrough inventions from conceptualization to commercialization to high-scale production or implementation. Good science policy can support economic recovery while also supporting environmental recovery. To do so most effectively, science policy, innovation policy, and climate policy need to be purposefully aligned. And this is an example of a project supported by PICS that's trying to look at that dual approach to investigating how do we decarbonize hard to decarbonize industries, such as emissions intensive trade exposed industries, while also helping to stimulate good jobs and social and economic value creation here in Canada. So I'm looking forward to hearing your ideas and insights, certainly the ideas and insights of the expert panelists with us today. And I'm going to now introduce you to our panelists. Our first panelist, Sabina Russell, is the principal and co-founder of Zen Clean Energy Solutions, a Vancouver-based consulting firm specializing in hydrogen and fuel cells. Sabina currently leads Zen's project management branch, focusing on consortium-based projects deploying zero-emission technologies and infrastructure. Her active projects span the full hydrogen value chain. Sabina also led Zen's work to develop the hydrogen strategy for Canada on behalf of the Government of Canada, and recently contributed to regional hydrogen strategies for Atlantic Canada and British Columbia. Thank you, Sabina, for joining us today. Our next panelist, Sami Khan, is an assistant professor in the Simon Fraser University School of Sustainable Energy Engineering, where he teaches graduate and undergraduate courses in clean technology. And his multidisciplinary research group is particularly interested in clean energy solutions in remote Canadian communities. Sami is a trained engineer, earning his PhD in mechanical engineering from MIT in 2020. We're delighted he's joined us at SFU. He has previously worked in the rare earth mining industry in Canada and was a science and technology advisor to the chief scientist at NRCan. Sami is a 2021-2022 Action Canada Fellow and is recognized as one of the leading young academics in his field. Welcome, Sami. Next, from Ionomer, giving us the industry perspective, we have Dr. Mike Admansky, who is an experienced award-winning chemist and materials scientist with a broad knowledge in design, development, and application of novel polymer electrolytes for electrochemical energy technologies such as hydrogen fuel cells. He received his PhD from Simon Fraser University following his participation in world-leading polymers and electrochemistry research under Professor Stephen Holcroft. At Ionomer Innovations, Mike continues his pursuits of decarbonization with industrial and academic partners, seeking to improve and commercialize groundbreaking ion exchange membrane and polymer solutions for clean energy technologies, including fuel cells, hydrogen production, and energy storage applications. Welcome, Mike. And finally, we have Dr. Aaron Hoskin. And Dr. Aaron Hoskin is a senior manager responsible for federal, provincial, and international activities within the Fuel Diversification Division at Natural Resources Canada. Aaron has over 15 years of experience in fostering greater production and use of low carbon fuels across the economy. He has also worked on the development of various programs and policies aimed at decarbonizing Canada's economy, including the hydrogen strategy for Canada, electrification of transportation, electric and alternative fuels infrastructure, and greening government fleets. Internationally, Aaron represents Canada on several initiatives under the Clean Energy Ministerial. Welcome, Aaron. We're delighted to have this expert panel that is going to debate the topic today about whether Canada can recover through taking advantage of our strengths in clean energy. We're also joined today by a graphics facilitator from Drawing Change. Her name is Kristen Elko, and she's going to be graphically recording our conversation, which means you'll see dialogues and ideas drawn in real time. So on behalf of SFU, thank you for joining us. I'm very excited to hear the opinions of this panel. Let's get started. So I'm going to start by asking the question of all of the panelists. Can you talk to us about the potential of the emerging hydrogen economy and the role Canada can play? And I'm going to start with the two that have dealt the most with Canada's hydrogen strategy, Sabina Russell and Aaron Hoskin. Can I go first to Sabina and then to Aaron with this question?
Sure, thanks, Alicia. Yeah, I mean, it's a very exciting time for hydrogen and for clean energy in Canada. We work very closely at NRCan to really look at Canada's whole energy system and say, how do we get from where we are today to a net zero future? And we know we're going to need all the tools we can have in the toolbox to get there. And hydrogen is going to be a really important piece of that. So, you know, looking forward, we think hydrogen could play a role of delivering up to about 30% of Canada's energy by 2050. And the time frame for different applications is going to vary by technology readiness, and there's still a lot of room for innovation to help accelerate. But we really see, you know, our hardest to abate, most difficult sectors are where hydrogen will play the biggest role. So if we look at, you know, transportation, it's going to be heavy duty trucks, the ones that have to carry big payloads. Probably we'll see both battery electric and fuel cell electric on light duty, but more battery electric because they can generally do the job quite well. Definitely on the side of heating, hydrogen can be burned and not produce carbon emissions. So where we need really high grade heat for industry can also play a really large role. And definitely when we look at how we stabilize the grid with more intermittent renewables, long scale energy storage, again, that's where hydrogen really shines. And then finally, hydrogen is used as a feedstock in a bunch of different industrial applications. So those are kind of the suite of technologies where we'll see hydrogen playing a role. And we really think we'll be using hydrogen both domestically in Canada to help us decarbonize. We need to urgently deploy hydrogen to do that. But also Canada has all the resources to be a really strong exporter of hydrogen to the rest of the world to help them meet their goals.
Aaron, I want to take the same question to you, talking to us about the potential of the emerging hydrogen economy and the role Canada could play. Can you build on Sabina's answer?
Sure, absolutely. Before I begin, I do want to acknowledge that I am speaking to you from Ottawa, the nation's capital, but also the traditional and unceded territory of the Anishinaabe Algonquin First Nation. And a real pleasure to be a part of this really great panel that was put together. I guess I would start by saying that what role can Canada play? We're already playing a leading role in the global hydrogen economy. for more than a century. We like to say in the strategy that the hydrogen story is really a Canadian story. For more than a century, Canadian innovation has put Canada at the forefront of the hydrogen economy. A century ago, we were filing the world's first patents for large-scale electrolytic hydrogen production, and companies like Ballard and Hydrogenics, now Cummins, continue to lead the world, deploying their technologies around the world and maintaining that world-leading pace-setting industry as well. And companies like Ionomer are helping them do that, right? To bring forward the next generation of materials that will be essential to continue to be at the forefront. So we're already leading the world, but the world is catching up really quickly. We're a major player, but we have a number of advantages. As Sabina said, the strategy for Canada isn't just about how hydrogen can bring economic and environmental opportunities across the country. It absolutely can, but it can also position Canada to become that supplier of choice to the world for clean hydrogen and the technologies that use it. We have advantages along the entire value chain. We have pretty much abundant feedstocks for every pathway to low carbon production. We have a low emitting grid, strong renewable potential, vast conventional resources, and world leading expertise in carbon abatement. And you heard about some of those technologies earlier on in the opening. And so all of those feedstocks position us to become a very large scale producer of low carbon clean hydrogen at cost, at a cost that's competitive with the rest of the world. I mentioned that world leading innovation. We have a strong conventional energy sector with extensive infrastructure that can be pivoted and remain competitive in a net zero future on the shoulders of hydrogen. We have long-standing international collaboration. More than 40 years, we've been working with countries like Germany, the European Union, the United States, the UK, Japan on hydrogen, and we continue to do so. And then as we become that supplier of choice for clean hydrogen, we already have existing export markets into the Asia from the British Columbia, for instance, into the European market from our Atlantic coast, and then into the United States from the world's longest non-defended border. So there was all of these unique advantages that really position Canada to benefit. Also, the fact that we provide the clean hydrogen and we provide the technologies that will use it. That's different than most other countries. Some countries, yes, they can provide large-scale hydrogen at a competitive price, but they don't always have the technologies involved as well. We provide both sides of the coin, both sides of that opportunity, and we can lever that to remain at the forefront of global deployment.
Wonderful. Thank you, Aaron. I'm going to pose that question to Mike slightly differently from the industry perspective, and as venture representing the potential Canada has within universities and spin-offs from them, and a company that could be exporting around the world, to Aaron's points. Can you speak, Mike, to the size of the opportunity for Canadian companies in the hydrogen economy, and what areas, in your perspective, Canada could be world leading between now and 2030? So in the next, within this decade.
Sure, yeah. So I think that the size of the opportunity is very large, and it's expanding at a rate it's very unexpected, especially over the last 2 years, as we've seen effectively exponential growth. So for example, we're looking at production projections on the order of millions of fuel cell electric vehicles by the year of 2030. And with that comes billions of dollars in demand for numerous subcomponents such as membranes and advanced polymers, specialized machining of metal components, and of course, the labor required for engineering and assembly of these kinds of systems. Tied to this is also the supply and production of green hydrogen for use as a fuel. It's expected that by 2030, the hydrogen economy will require upwards of 300 million kilograms of hydrogen per day, which means deployment of massive electrolyzers and electrolysis stations is required that are today just being planned. As Aaron and Sabina already mentioned, Canada is already a world leader in electrochemical research and development and manufacture of electrochemical systems. So we have both the technology and the systems available for things such as hydrogen fuel cells and fuel cell electric vehicles. I expect that we'll see continued growth in these areas. We are well known for our research in fuel cell electric vehicles specifically, but at the same time, I think we can strengthen our position in hydrogen, in green hydrogen production via electrolysis, specifically anion exchange membrane electrolyzers, which is a primary focus of interest, as well as design and development of advanced components such as membranes required by these systems. So I think in short, the opportunities are enormous right now. for Canadian companies, and we're already in an excellent position to be a world leader in hydrogen by 2030. But I think what we need is the right funding and strategic investing within Canada, which is specifically directed towards the hydrogen economy and its infrastructure.
Thank you, Mike. And Sammy, on this question, as a thought leader in academia, I would speak to this potential, including that is of the technologies that can be developed by 2050 for net zero. As I mentioned earlier, the International Energy Agency says that 50% of these technologies are still in research labs or undeveloped. And as a thought leader who's developing some of these technologies, can you tell us about some of your research that could be game changing by 2050, or other research that you're aware of in Canada, in academia? And maybe speak to any of the uncertainties or key cost drivers that need to be addressed to get us there.
Yeah, thanks, Alicia, for the question. So broadly, for clean energy advancement, you can think of two levers that we can have. One lever is a materials or mass-based lever, and the other one is an energy-based lever. So to explain that, I can give an example of boiling water or just having a pan of water that you have to evaporate. So you could either put in energy and then cause this water mass to evaporate and spend that additional energy that's needed. Or you could use paper towels, which is a material or a mass-based approach, and then spread that same volume of water into these thin liquid layers that are held within the paper towel that then evaporates quickly. So this is what my research group is interested in doing. If we can harness these materials-based solutions and then use innovative interfacial engineering approaches, then overall the net energy that gets put into taking a clean energy process to fruition can be reduced. And that's our driving hypothesis. Now, there have been many innovation in materials and labs around the world, but they've been obfuscated with publications and being in journals and not out there. So it is important to have these conversations where innovation in the labs, especially on the material side of things, is explained well to the general audience. And this is the kind of education we are giving to our graduate students and encouraging them to do the fundamental research, but then also participate in broader conferences. And as an example, my student recently participated in a 3-minute thesis competition where they had to explain their research in very simple layperson terms to a general audience. And this is where this kind of education will be needed. Now, to your question about cost drivers, so materials that are earth abundant will be very important. And this is the kind of focus that our group is interested in. So using materials like copper, which can be used to drive catalytic reactions, rather than materials that are harder to synthesize and may take more energy.
Thank you, Sammy. Now, Sabina, I want to cycle back to you as an author of the Canadian Hydrogen Strategy, of thinking of uniting these perspectives, industry perspective of what's happening now in the shorter term, to the academic perspective of what's happening in the longer term, but we still need for net zero 2050. And we still have opportunities in Canada to be able to develop and participate in that economic growth from those opportunities. Can you speak to us about what, in your mind, are short-term, medium-term, and long-term opportunities for Canada in this clean energy transition, and particularly with a focus on hydrogen?
Yeah, thanks, Alicia. First, I want to say I really applaud NRCan and the Government of Canada for setting a vision, because that's something that we can find and work together, as you said, over the short, medium, and long term. And so I think now we really understand collectively, from the academics to people in industry to people writing policy, where we need to go, where we're trying to go. And now it's time to start getting there. So when we look at the short term, it's really important to understand technology readiness levels of the end use solutions and also the production technologies, and also understand some of the economic challenges we have. So in the near term, what I would say is what we're really focused on here in Canada is establishing hubs across Canada where we can develop both supply and demand at scale in a concentrated geographic region, because that's how we can really bring everyone together, show the benefits of hydrogen, create almost like living lab environments for our academics and researchers to learn, try technologies, but also deploy at scale those technologies that are ready today. Technologies that are ready today, I drive a fuel cell vehicle and I fuel it here in the network of fueling stations in BC. So light duty passenger vehicles, we have them in BC and Quebec in Canada today. Transit buses are also very commercially available, mostly deployed in California, where they have a very strong mandate for public transit moving to zero emission. But we also see sort of newer applications emerging that have really been led in Europe, like blending hydrogen into natural gas and combusting a mixture. So if you put in 10% hydrogen into natural gas, you roughly reduce the carbon emissions by 10% as well. So it's a way to decarbonize heating. Our pipelines today can accept blends up to 20%. It depends regionally in Canada. But to me, those are really ripe for near-term change. And then even in how we make conventional fuels. So today, Canada is one of the top 10 producers of hydrogen. It's mostly gray hydrogen through steam methane reforming, but we use it for upgrading and producing gasoline and diesel. And so if we can convert that to clean hydrogen, that creates really strong demand right away in existing processes to bring hydrogen at scale. So that's the near term. Over the midterm, what we're already seeing pilots of sort of the next suite of technologies that are coming. So for example, in transportation, trucking would be one that is moving next. And we know we need Class 8 trucks. Hydrogen has such advantages for gravimetric energy density. So if you're trying to move a lot of goods, you don't want the weight of your truck to be carrying your batteries around. You want your fuel to be as light as possible, your powertrain to be as light as possible. So trucking is a big emerging sector. And then lots on the industry side of things as well. So making renewable fertilizer, so looking at ammonia production for fertilizer here and decarboning our agricultural sector, but also using that as an energy carrier to move hydrogen at scale from Canada to other regions. That would be something that I think is going to be happening in the midterm. And by midterm, it could be 5 to 7 years where we're seeing these at scale. And then longer term are all those other kind of lower TRL applications that we're working on. So liquid synthetic fuels, we've talked about carbon engineering, where you take, renewable hydrogen and you combine it with a CO2 captured from direct air capture technology. The technology is working today, but getting the economics there will take a little bit longer. And that can be used for things like aviation applications, where they're exploring use of synthetic fuels, but also directly use of hydrogen in turbines or in fuel cells. So that gives you a sense of, the timing of some of these different applications across Canada.
Fantastic summary. Thank you, Sabina. I'm going to turn to Erin now, but I'm also going to turn to the science policy and the innovation policy that we think can get us there to support Canadian companies in developing and academic spin-offs as well as in developing some of these technologies that can meet some of these opportunities and then grow and export around the world. I note that you spoke there, Sabina, about the California using our fuel cell fleets and fuel cell buses, and I think also that London double deckers are running on Canadian fuel cells, and maybe that's an opportunity here in Canada. But I'm sure we'll come to that part of the conversation. And first, Erin, I want to turn to you to think about if there was one science or innovation policy that you think is most important to getting us to realize the opportunity that we have from the hydrogen economy and from clean energy transition. What would that science innovation policy be? And I'm going to ask that to the other panelists after, but I want to lead with Erin.
It's a really difficult question. And it's interesting because I started my career in the government in a lab. And so I kind of have transitioned from being somebody in the lab doing that fundamental bench scale innovation up to now, working on policies related to zero emissions and how to put Canada in a position to meet our long-term climate objectives. And I don't think you can separate the two, right? You need to have science and innovation to inform the next round of policy development, but you also need to have policy can be policymakers that can speak to scientists and understand the lingo, and those don't always mesh up, right? But you really need to have those bridges, and science and policy integration is essential to moving forward. And I think NRCan has tried to do a really good job at integrating both together. That said, if I had to choose one, I think it would, well, I think it's probably a combination of two different things. One is that hydrogen and the need for low carbon fuels and electrification need to continue to be part of our long-term climate and sustainability policies. You need that long-term signal on the part of government, that long-term signal that hydrogen and clean fuels will play an essential role in a net zero future, will help enable the next generation of innovation to happen, right? By providing that signal, it locks in private sector investments. It helps early adopters see that if they adopt hydrogen now, it's not going to be a stranded asset in 5 years because the next new thing comes down the chain. And so those long-term policy signals are essential, both to growing the deployment market, but also to continuing on the innovation side of things. And then I think you have to match that policy signal with measures or instruments that help support and de-risk early investments, again, across the value chain, from fundamental RD&D to demonstration to full commercialization. You can't necessarily have a policy in and of itself without having some kind of measure or measures in place, whether that's regulatory measures, fiscal measures, or a combination of both, to enable that policy to happen. The way that we develop policies and programs in NRCan is essentially linking both together. We have teams that are composed of policy analysts and program delivery agents, and they help inform the next round of policy. And I think that that's essential. Again, actions across the entire value chain, because as those early adoptions start to happen, they can inform the next round of innovation as well, right? And so you can get this continuous feedback loop where early adopters help inform the realm of the feasible for the next generation of technologies, but also that helps push forward on the next round of policy development. So those are kind of the one broad brushstroke policy that I think is essential.
It is very hard to pick one policy, and you did a masterful job of actually picking, two, but integrating them together in a way that I think, we'd agree has to work together in order to get us, to the next step. Both the signaling, the long-term signaling, and the shorter term supports in de-risking and getting adoption. And that leads me to take the same question over to our industry representative, Mike. If you could pick a science or innovation policy that, from your perspective, is important to getting Canada there, what would that policy be? I think you're muted, Mike.
I came to that conclusion myself. So thanks. I think the one thing that comes to mind from my perspective is funding and programs that are specifically tailored to development sort of projects within Canada as much as possible, or within North America if that's not possible. So, for example, where there are opportunities for cross collaboration to develop systems utilizing all Canadian technologies and components. I know that the U.S. Department of Energy and its constituent national labs and corporate affiliates do an excellent job of this, and they are a pretty good example of this, where strong collaborative efforts have produced numerous world-class technologies, including some of the first-generation hydrogen fuel cells that were used to, for example, go to space. So that would be sort of the primary focus, just programs that help Canadian companies work together really strongly, because I think we have everything that we need to develop these systems to higher levels. This also kind of ties into setting up standards and formal reference platforms. This is something that is also done by those sort of national laboratories, where there's a fundamental need to have a sort of a certifier or a clearinghouse for validating and standardizing component advances, similar to what the National Renewable Energy Lab in the US does, or what the Fraunhofer series of labs do in Germany for photovoltaics. So something like this could be implemented into these specific programs to sort of have innovation excellence effectively across Canadian companies and labs.
Great, thank you, Mike. Sabina, over to you. There's been some great policies already chosen. Would you choose one of the same, or to you, what is one of the most important science that you think will be important to getting us to benefiting from the clean energy transition economically?
Yeah, maybe just to be a little bit different. One thing I would say is there's nothing that creates innovation, change, rapid progress, and an urgent call to action will make us change and innovate quickly. And so one thing I would suggest is to say, now is the time. There's no more like future planning, but to really signal that the status quo is no longer acceptable. And so, I look at things like ZEV mandates. In California, I talked about buses. We have the ICT regulation there that says government will no longer procure public transit buses unless they're zero emission. And to me, I know it's not exactly related to science and innovation, but I'll tell you, when in 5 years, you need to be buying a solution that's not quite there yet today. Industry, academia, they come together and they figure out how to make it happen. And we've seen lots of examples of that. And so that would be the lever I would pick, is just to say the status quo is no longer acceptable. Set the timeline to say at this time, no more distributed combustion in city centers, no more, combustion engines, and pick where we see, the greatest change is needed, and just start implementing that as soon as possible. I think you're muted, Alicia.
Thank you, Sabina. I absolutely see that as related to science and innovation policy. It's the mandate and the setting of the vision. I agree, a hugely important signal and aligned with mission-oriented innovation. So thank you for that. And Sammy, to you, picking a science policy or an innovation policy that, from your perspective, would be particularly important.
Very much agree with my fellow panelists. I would add that a key intermediate step between the innovation that happens in the lab and then scale up to market is a proof of principle pilot scale demonstration for feasibility. And this is why I see a great opportunity for policies and programs in Canada for rapid acceleration. And Mike interestingly mentioned the Fraunhofer Institute. I was in Hamburg last week at the Fraunhofer Institute, and I had the opportunity to ask questions about how they're accelerating some of the grassroots innovations that are happening in their lab. And that's where they have collaborations with fundamental institutes like the Max Planck Institute. And they provide access to experts and infrastructure to the graduate students and the scientists working in these fundamental labs. So it creates that appetite that if there is that innovation, then there is this infrastructure, there is this expertise that is available to accelerate it. And then also very importantly, space, because some of these pilot scale demonstrations take up space. So I was in Denmark after my Germany trip, and I found out that they are reusing some of their shipping containers to serve as pilot scale demonstrations for carbon capture. So this I found was very innovative, and this is something where we could also implement similar programs.
Thank you, Sammy. I'm going to reverse the order of the next question because it builds on what you've just said. And I'm going to ask you why, in your opinion, in Canada, is there such a gap between our level of excellence in invention in the hydrogen economy versus the traction we've had so far in innovation? And then I'm going to go to Sabina and Mike and to Aaron. So for you first.
Yes. So to clarify me first, Alicia?
Yes, please, Sammy. So why, in your opinion, is there such a gap between our level of the invention in the hydrogen economy? Clearly, Canada has been such a leader here, and stretching back to NRCan, IFC, and to Ballard in the early days. But the traction we've had so far in innovation versus other countries in the world, why do you think there's a gap right now?
I could give the perspective from the academic setting. So, this cross-pollination and discussions between graduate students and academic researchers and industry experts and policymakers Frankly, the Canadian Science Policy Conference is a great example of facilitating these kind of conferences, these kind of dialogues, and we need more of those. So having these very locally in every province where there's interactions between researchers and industry experts as well as policymakers at every level facilitates conversations, facilitates discussions about scale up. And again, just with the trip that I had mentioned, I've had the opportunity to ask these questions, and there are forums where these kind of discussions and dialogues happen. So I would say that that would be one of those avenues with which that gap can be overcome.
Okay. So the conversations that we're having today and having the multi actors and the different perspectives in the same room, or in this case, Zoom room, is a great start. Clearly, the kind of strategy that NRCan has been putting together, and that Sabina, you've also been involved with, is a key way of starting to, to change our record in getting invention to innovation, which is not just specific to hydrogen. It's across, deep tech that we have, and it's a challenge for many countries. But maybe I would go next to Sabina on that same question. Do you agree with me that we have a big gap between invention and innovation in the hydrogen economy? And why, in your mind, is that?
I do think there is a gap. I think that in my mind, one of the big problems we've had is we just haven't been deploying here at home. So we have these great inventions, and then we're selling our technology out to other parts of the world. And, to really take it to that next level, you need to get your hands on it. You need to try the technology. As somebody who's now driven a fuel cell car for, how long have I been driving one? 2.5 years. But I developed them for so many years at Ballard, and then I worked on fueling stations. But until I started driving one myself and observing certain things about that user interface and how you feel during fueling, I mean, it just makes such a difference. And so from personal experience, I can say it's so important that we have hydrogen here at home. We build awareness. We allow our scientists and our engineers to use the technology every day and come up with new ideas. And so I think part of the gap is we haven't had it here. And why haven't we had it here? There's been a gap in the policy that supports, the deployment of it. And things like, mandates to get rid of combustion engines, those types of things help a lot. But also just saying we need to get to net zero will naturally lead to us getting all of these solutions here at home, because we know we need all the tools in our toolbox. So I think these hubs will really be a great starting point for us. And we're ready to do it now. They're forming. We want to have 30 of them, by 2030 here in Canada. And I think we're going to see incredible innovation as a result of that.
Fantastic. I'm going to go next to Aaron and then to Mike, given the way that your comments have gone. So, Aaron, your perspective both on why we have a gap and on these, exciting developments of the hubs to get beyond them.
Sure, and I would say that the gap only exists, or only started to exist, about 10 years ago. I mean, Canada had the world's first large-scale deployment of fuel cell buses, right? In Whistler, BC, 20 buses that were part of general day-to-day operation. We had the world's first installation code that enabled retail sales of hydrogen fuel, and the build-out of stations. We had that 15 years ago. Where the gap started to happen is when, for the most part, and Sabina will probably correct me on this one, but early adoption was really focused on the light-duty passenger vehicle space, and then there was other things like forklifts, and we know that materials handling was actually a market that went forward. But the perception was it was buses and it was light-duty passenger vehicles, and then very quickly the battery electric vehicle in the light-duty space came. You had vehicle manufacturers coming with product to market, and it took over that sector really quickly. But that's where things again have changed on hydrogen. And when I present on hydrogen, I like to say it's a perfect storm, although I was chastised the other day because people said that a perfect storm has negative connotations. But it really is, it's that pinnacle of policies and evolution of technology now that have opened up so many other uses of hydrogen that now again, the global economy is starting to look at hydrogen. It's not just about light duty passenger vehicles. Global policies, global climate change and energy security policies have brought hydrogen to the forefront. As Sabina said, when countries around the world, Canada, the first to legislate it, signed on to being net zero by 2050, that was the start of the game changer for hydrogen. Hydrogen is one of the only options to get us there. But also, unlike 15 years ago, the hydrogen opportunity is now, you're seeing conventional energy companies come to the table, you're seeing governments at all levels, you're seeing clean tech companies across the entire value chain, you're seeing gas utilities and electric utilities all coming together. That didn't happen before either, right? And so you have everybody at the table, and that's why the concept of these hubs are essential as well, because it continues to do that. As the business case for any one end use grows, hubs enable pretty much action across the value chain, ensuring that supply and demand grow at the same pace, and ensuring that we can lever all of those advantages. And it's also about building capacity. Sabina mentioned the need to have the next generation of engineers understand hydrogen. You also have to have the next generation of policymakers understand the opportunities for hydrogen as well. And so it really is starting to snowball. I think Mike had mentioned that global investments are astronomical, and they continue to grow at exponential pace. In the last 18 months, upwards of $200 billion have been committed, actually committed globally on hydrogen. So the world is catching up. Our companies hopefully will maintain that world leading position. But it really, as Sabina said, we haven't had that domestic market. Our companies continue to lead the world. They continue to sell globally. But I think for a few years, Canada's focus on reducing emissions from light duty passenger vehicles was just on battery electric, and that kind of pushed hydrogen a little bit to the side. Doesn't mean our companies stopped innovating, and our universities, they all kept going forward. Just, I would say, at the federal level, the focus changed a little bit more to battery electric and light duty passenger, and that kind of delayed activities on hydrogen.
So I think our audience would like to hear, and I'd like to hear a little bit more about these hubs. And I'm going to ask both Aaron and Sabina to elaborate a little bit. But before I do, I want to allow our industry speaker to speak to that last question, which is, did you feel that gap between our inventive possibilities in Canada, specifically around hydrogen, and the innovation that we're able to, the place that we're taking globally in innovation? And how did you feel it at Ionomer? And do you think that, to the points that Aaron's made, that this is rapidly shifting?
So I think Aaron's points are absolutely excellent. Sabina made a few points that overlapped as well that I truly believe are representative of the current status quo. We have felt that Canada is sort of behind, and this is sort of really well demonstrated by just the scale at which Canadian companies are showing interest in procuring and deploying their own technologies and next generation technologies that incorporate materials such as ours versus those from the EU and from the US. The level of deployment and the scale is much lower in Canada. And I think that we are catching up. I think that everything in the hydrogen economy is taking off now, and Canada is being swept in with it, which is a really good thing. I want to offer a slightly additional perspective to this because most of my points were actually made by the former two speakers, which is very convenient. But I think the current suite of clean tech and deep tech funds from the Business Development Bank of Canada are really great at capturing the early stages, so the invention and the breadth of innovation. But I think that their additional fund of funds model needs to be a bit more prescriptive to specifically investing within Canada and investing in the hydrogen space. So this is happening now. So again, this point might be slightly moot as this development continues to accelerate towards hydrogen. But I think that there is a good amount of focus towards, for example, fundamental R&D in universities. But once that becomes implementation and actual innovation, the funding isn't akin. There isn't the same level of funding. It doesn't scale accordingly, I think.
Thank you, Mike. I did want to say to our audience here today that we are about to turn to your questions shortly. So I do encourage you to type them in as we go, and the panelists and I will incorporate them into our discussion here. But first, Aaron, back to you with telling a little bit more about these hubs and maybe giving us an example of how one of them will work.
Muted and turned off my camera. Anyway, you'd think after 18 months of this, we'd all be in good shape, but I guess not. So hubs are a concept. It's not unique to Canada. Various countries call them various things. Austria calls them hydrogen valleys. We've heard hydrogen beachheads. I would note that the U.S. Bipartisan infrastructure plan that was released last week included $9 billion in investments, including significant investments for hydrogen hubs, dedicating 4 hydrogen hubs. The concept is really meant to bring together key stakeholders or indigenous groups or academics across the value chain. So producers, distributors, end users, multiple different end users, and kind of these multiple component or multiple phase projects. There's no one size fits all. A hydrogen hub in Vancouver, low mainland BC, could be very large with large scale production, export potential, decarbonizing a port, municipal transit, various other fleets, all building off each other, versus a hydrogen hub that could exist in, say, Atlantic Canada that might be smaller, just based on the varying sizes and jurisdictional locations. But the whole concept is that all of the key players come to the table, governments at all levels as well, and work together to ensure production and use grow at the same pace. So supply and demand grow at pace, but also they start to build capacity based on the strengths of that specific region. So it's like a regional deployment center, virtual center, and I'm sure Sabina can do a much better job explaining this. But it's really meant to help, or hubs are based on the specific unique advantages, unique end use potential in a given jurisdiction where everybody comes together and builds forward together. And then the overall concept is you could have, let's say, a hub in the Alberta Industrial Heartland, which is probably the first hub that's coming together in Canada. Certainly we're getting some indication that there's activity happening there. And then another hub in Calgary, and the two kind of hubs grow capacity in their own little jurisdictions. And then that capacity grows over time to the point that hubs then connect, right? And they become hubs and spokes. And then eventually that patchwork of key deployment centers grows to the point that you get that cohesive coverage across the country, but everybody still has their own opportunities, and it still builds off the unique strengths in the various different jurisdictions. And that's really why these subnational roadmaps and strategies are also essential, because they help bring together those stakeholders. They help bring together all of the key parties and really focus on what are the strengths in that area, understanding that those strengths and opportunities evolve over time as well.
Wonderful. I'm going to ask Sabina to build on that description, but I'm going to encourage, I've been noted that the place that the audience can ask questions or comment on the points that have been brought forward by the panelists is in the live Q&A. So you'll find an icon that you can click on, and you can write there questions to the panelists and or building on some of these points and examples. And Sabina, back over to you for maybe another example. I think Aaron's covered it very well, what the knowledge hubs are, but maybe there's another example that you wanted to bring forward.
Sure. Yeah, I think Aaron captured the idea of what a hub is very, very well. And I think I'll just build on the point that hubs forming regionally based on what the local energy resources look like, what the local industry looks like, even some of the sort of geological formations in an area. If you're able to store carbon, you might have a different type of hub than if you have big wind resources. So I'll give you an example of one that's looking at export as well, because that can also be an important part of a hub that creates even more scale than we can with multiple end uses locally. So Prince George in BC would be somewhere, if I were to map out 2 hubs in BC, I would map out, the Metro Vancouver area and Prince George. And why Prince George? Well, you've got a lot of important industry for BC that needs to diversify today. So the pulp sector, for example, they use a lot of energy for heating in their lime kilns. They're getting into biofuel production. They could naturally become producers and users of hydrogen. You've got Prince George nearby, which is a strategic port to be able to export hydrogen or ammonia to Asia. There's a lot of trucks that drive through that region as well. It's a cold region where we need, heating. So there's a whole bunch of different applications there. And what we're looking at in Prince George would be green hydrogen, or hydrogen made using electrolysis from renewable energy. We have Site C Dam coming online. There's major transmission lines that run right to that area. And there's also a lot of wind resources that are being developed in that region. So it just gives maybe a real world example of another hub that's kind of organically forming by various industry members that are seeing, hey, I need to use it in this way. And I want to produce it at scale to be able to export it to Asia, but I'd like to be able to decarbonize locally as well. And so we've been involved with a lot of players, both on the production and end use side, and we're trying to piece it together. And the one thing I would say is it's hard right now to do that. You need somebody to take the lead to say, well, wait a minute, I'm going to not just think about myself here, but put all the pieces together. And I think what's exciting is to see some policy change coming where government will play a more active role in saying, okay, well, let's look at these hubs more holistically. Let's provide maybe single points of funding. Right now you have to go for separate funding for, the vehicles, for the production, for the pipeline connecting them. So just to simplify it, to get them going faster, I think there's some great momentum happening there. And BC, with the hydrogen strategy that was announced, is looking specifically at that. So how can BC lead? By having government, have a specific hydrogen hub fund. And so I think that's part of why we're seeing this momentum in Prince George, for example.
Thank you, Sabina. Now, that question makes me think to go to both Sammy and then later to Matt from the academic perspective. And I know you're going to be speaking from your own research and your own product development, but could you give an example of how potentially you, Sammy, could participate in one of these BC hubs, be it in Metro Vancouver or in Prince George? And then I would ask the same, Matt, of you in terms of Ionomer, how they might. So just to make it tangible for our audience, how research at these different stages might get incorporated into a hub strategy, such as has been spoken about by Aaron and by Sabina. Sammy, to you first.
Let's see safety being one area. So in terms of hydrogen, with hydrogen transportation and pipelines and storage, there can be concerns with hydrogen embrittlement, where hydrogen gas can permeate through these metals and then cause some safety concerns. Now, Canada has had, in the nuclear industry, a very strong record of codes and standards with a high degree of emphasis on safety. So this is where academic research can intersect with the development of codes and standards within these hubs. And as an example, having a protective coating which can be applied on the inside of these pipes that is able to stop hydrogen embrittlement from happening can permit the usage of existing infrastructure to transmit hydrogen. And this is where graduate students in my group could benefit from visiting these hubs, which Sabina and Aaron have described, and then also having these conversations around safety.
Examples. Thank you, Sammy. And Matt, over to you for the same question.
Remember to unmute this time. So from my perspective, the hydrogen hub idea is an excellent idea because logistically speaking, it's very cumbersome to get hydrogen certified and to build hydrogen safe labs and to plumb in hydrogen, and everything revolving around hydrogen has a lot of safety implications that slows down how quickly you can use and utilize such areas such as a hydrogen safe lab. So a hydrogen hub that has something like this, where, for example, industrial partners can come in and use a fuel cell test station or run an electrolyzer and cross collaborate with other partners as well, seems like a really beneficial setup for everyone involved. So I think just the ability for mutual shared lab space that's all hydrogen certified at a hydrogen hub, where you can exchange ideas and learn from one another, it just sounds like a fantastic establishment.
Thank you, Matt. So we spoke a little bit earlier. We do have a question that's come up in the chat that I wanted to give to our panelists. I think Sabina, you touched on this a little bit earlier, so you might want to again. And the question is about hydrogen fuel cell vehicles overtaking electric vehicles or being in niches. So it's saying, do you see hydrogen fuel cell vehicles overtaking electric vehicles in the future? Or are the two technologies going to exist alongside each other, perhaps in different niches? Do you want to elaborate on that?
Yeah, I mean, I absolutely think that they're going to exist alongside each other. I think each has its advantages. I've never believed like we should be pitting one technology against each other. I think we're going to need the whole suite of them. And so, I look at light duty, and yes, I drive a fuel cell electric vehicle, a light duty one, but I don't think I'll be in the majority. I think that most of the light duty vehicles drive shorter distances. Battery technology is evolving. So I could really see more battery electric and light duty, for example. We work a lot with transit agencies in really hot desert climates in California, and we're working more and more with Canadian agencies in really cold climates that often travel much longer distances. And I think even within agencies, we'll see a split of the two. So, for shorter routes, because often it's actually more optimal for them to have both types of fueling infrastructure. With battery buses, it's easy to add one charger per bus you bring on. But when you're starting to look at a whole fleet and you're starting to look at climate change and the impact of these very significant storms in California, we'll have brownouts planned, like for 4 days, you'll have no electricity at your transit yard. What do they do if they only have battery electric buses? How do they pick people up? How do they charge them? Are they going to have a giant battery wall that provides charging for buses for days? They can't practically do that. So I think that they're looking from a resiliency point of view at even within a transit yard, having both technologies doing different jobs, but also giving them diversity in their energy and fuel source for their fleet. So I do think some applications we will see, more of one than the other, but I think in many applications we'll see both alongside each other, even just doing slightly different routes or different jobs.
Thank you, Sabina. And Mike, I would take the same question to you, and maybe you could some of Ionomer's products in this space, but also how you look at if you're looking into your crystal ball, where fuel cells will play a role in transportation versus electric vehicles.
So Sabina made a really good point that it's really not a good idea, I think, to look at it as a competition, just because any sort of progress we make, be it battery or fuel cell electric vehicles, is a step in the right direction, ultimately. There's also a differentiating factor because it seems that batteries are quite suitable for low weight, so like passenger vehicles. But when it comes to refueling and long distance driving and when weight really matters, that's where fuel cells seem to be taking the edge and really shining. So I think one of the most imminent deployments of fuel cells is going to be in heavy duty trucking, just because of the charging implications and distance driving requirements. So I wouldn't really call it a competition as much as sort of a synergy that is working together to decarbonize the entire usage of fossil fuels in transportation. And I actually forget the second half of your question. So
sorry, the second half of the question was if maybe you could speak to some of Ionomer's products in that space and why they're why they could even change some of that adoption.
Sure. So we have two different primary product lines. They're geared at very different aspects of the hydrogen economy, but they fundamentally fall under that umbrella. We have Pemion, which is a proton exchange membrane that is suited for hydrogen usage applications, namely hydrogen fuel cells. And we have amnion, which is an anion exchange membrane, and that is suited for hydrogen production applications, such as green hydrogen production through electrolysis. They are definitively different, but at the same time, they are useful for the same general purposes and for the overall story of this hydrogen economy. From the amnion perspective, this one's a little bit easier. We have really the only membrane solution available that enables the use of the lowest cost and greatest, simplest to scale technology of electrolysis, which is anion exchange membrane electrolysis. So I think with this technology, we're enabling partners to deploy massive electrolyzers that were only dreamt of or planned even just a couple of years ago. From the PEMion or PEM perspective, we have a material that is definitively different than the incumbent in the market right now, in that it is completely fluorine free. And this is an interesting development on its own, because there's a lot of targets now from the EU, for example, to eliminate perfluorinated compounds, be it from materials that go into fuel cells to clothing to packaging. And the materials, like I said, that are used in fuel cells now are perfluorinated and are targeted by these types of bans and restrictions. So it's development of a material that will be usable if these types of things come into play. Because if these types of things do come into play, it's a much bigger story than just hydrogen. It's, the health and safety of everyone on the planet. And it would be a hindrance to the deployment of fuel cells. So we're not at odds to these types of things. And it's hard to pick the greater good between, deploying hydrogen fuel cells or preventing the use and manufacture of these types of chemicals. And we don't have to make that choice.
Thank you. So again, I encourage questions from our audience today into the Q&A, the live Q&A, and we'll get to them. But at the moment, I wanted to ask our panelists I wanted to pick up on the procurement idea that we spoke about earlier, that some other regions have been doing, that we're starting to do, and we have done, as Aaron pointed out, very effectively with the Whistler Olympics and the fuel cell fleets of buses there. And we had a pause. But if we were to pick right now, we talked a little bit about the hubs and the regions. If we were to pick a sector where procurement policy could make the biggest difference to developing strong hydrogen innovation ecosystems, and I know that's a bit unfair, there's probably multiple, but if you could each talk to a sector where you think it could make a big difference, it could be, marine or rail, it could be, in our petrochemical industry, speaking about, blue hydrogen, for example. Could you speak to something where procurement policy could make a big difference to developing a strong hydrogen innovation ecosystem? And I'm going to come first to Aaron.
So one thing the government of Canada has committed to doing, and it is part of procurement policy, is related to greening of government operations. And so we're not just expecting Canadians to adopt clean options or low carbon options in their day-to-day lives, including zero emission vehicles. We at the government of Canada have committed to adopting zero emission technologies in our own operations. A big part of that is vehicle deployment in government fleets. We have commitments to have 100% zero emission vehicle deployment before 2030 in government fleets. And so that starts to build that procurement, right? And we're working with subnational governments, with municipalities to help do that as well. We know that in the US, for instance, there's been good traction on having cities partner together, because smaller municipalities might only need 5 or 6 fuel cell vehicles or 5 or 6 zero emission vehicles. But if you can partner up 10 of those, you get a better price point, because now you're ordering 60 of technology X, Y, or Z, right? It doesn't have to be on zero emission vehicles, but that's just one that the government of Canada is doing. And so it's really that group buy concept. It's bringing together like-minded regions to help adopt technologies at scale, and with a focus on greening operations in government procurement or greening government procurement policies. I think that's kind of one key area. And again, that helps build confidence as well, right? If you can imagine having government vehicles, and we're already seeing it. One of the, Sabina mentioned earlier on the hydrogen stations in Quebec. one of the vehicles refueling at that station is actually the head of border services in Quebec, who's driving a fuel cell vehicle as part of greening government operations commitments. And so it's really putting action to words, leading by example, getting fuel cell technologies into the marketplace on the shoulders of government, so that people can see them, people can get accustomed to them being on their streets, driving down the street, being part of fleets that are out there, and then that helps build that public awareness as well.
Thank you, Aaron. I'm going to send that same question next to Sabina. If you were to pick a region and/or a sector where procurement policy could make the biggest difference to developing strong hydrogen innovation ecosystem, what would you pick?
I think Aaron did a great job of talking about the public sector. So I think I'll put it out there to say, for the private sector, if every buyer just with the stroke of a pen started to change some procurement policies in their own organization, and to say, when we select a vendor, environmental performance is going to be part of the selection. So, and whether that's a pulp mill choosing who their truck operators are going to be, to say they must be zero emission trucks that deliver our pulp products to the drayage center. Those kinds. So I think private industry can play a huge role just by being thoughtful about it and setting targets and setting it as a criteria for selecting, vendors in their supply chain.
Sabina. Mike, over to you for a procurement policy that you think would be really helpful from an industry perspective, and particularly from my honor's perspective.
I don't think there's a specific region, but there is a sector, and that is, as Sabina said, the private sector, so industry. I think this could make the biggest difference. I don't think there is even a comparison, because public, and there's buses and there's government and whatnot, but I think the private industry is so massive. And like Sabina said, just by changing a couple pen strokes and occasionally ordering something that uses or produces hydrogen, that would make a very big difference in the grand scheme of things. It's really just about deploying the technology. Where is it being used? How do we reach that mass adoption? I think industry needs to recognize that the cost might be a little bit higher at first, but it is for a greater good. And actual implementation of these technologies is key to developing these strong hydrogen innovation ecosystems. And I think that at the moment, procurement of these technologies in Canada is actually generally slow. So as a good example, Hydrogenics or Cummins, which is a Canadian company that produces fuel cells for heavy industries such as trucking and rail, they've got numerous orders and customers across the globe, namely in the EU, but see very little implementation in Canada. So I think just by adopting similar procurement strategies to European companies, Canadian companies could make the right steps now to change their implementation rate.
And how does that work in your perspective? Is that government setting an envelope within the procurement policy for industry? So the companies that are buying in from European providers, for example, there's a government role in that?
I think there is. I think maybe it's not as definitive as a policy, but there's a mentality about adopting these new technologies that seems to be much more pervasive in Europe than it is here. And I think government could influence that just by even, maybe it is a policy, but maybe some sort of a nudge to say, hey, this technology is ready to go, and look, you can make these changes now.
Or Aaron, would you like to talk to that?
Maybe I can jump in for 2 seconds, just kind of building on that. I think there's always a role for public and private sectors to work together. The strategy is very clear that, it's neither on the shoulders of the private sector, nor on the shoulders of the public sector, nor academia, nor indigenous organizations and businesses. We all have a role to play, and it's all synergistic. We can't do it alone, and we certainly can't do it even just within Canada. We have to build off the international perspective. But one thing the private sector can do on the procurement side of things, it's not just about adopting the technologies in their operations. It's also about those ones that do adopt becoming ambassadors. Yes, it's probably benefiting their bottom line in the long term, but also, like, I'm sure the public would like to know that if you go into a Costco in parts of Alberta, every piece of the product that you're picking up has been touched by a forklift that's been running on hydrogen. Most people in the Calgary area don't know that, right? Or, you know, if you go into Canadian Tire in the Greater Toronto area, most of the products there have been moved by a forklift running on hydrogen because these companies have already chosen to adopt hydrogen in their day-to-day activities. That message doesn't always get out there, right? And I think it's not just about adopting procurement policies within your own operations, it's also becoming that ambassador and helping people understand we did it, we benefited. Yes, it's benefiting our bottom line probably, and they probably won't get into the business aspect of it, but certainly that long-term sustainability, it's not just about adopting, it's about replicating thereafter as well.
Great, thank you, Aaron. Now, Sammy, you haven't weighed in on this question yet. I know you're joining us today from Norway, and you've just been in Germany. Was there a procurement policy there that you saw or noticed that you think we could benefit from in Canada, or do you have another idea for a sector or specific procurement policy?
Yeah, so I was pondering on this as the panelists were speaking about public versus private, and realizing that, you know, universities have the ability to be autonomous in some ways to demonstrate sustainability initiatives on campus. So, you know, here at SFU, we have the Living Labs, which is a great initiative to pilot, you know, any kind of innovation that's happening, but also universities are a great microcosm of piloting such initiatives before they make it out. So, so I would say that that's something that I've seen extensively in my travels in Scandinavia across different university campuses, where student groups are meeting with university officials and making it clear, you know, simple things like ordering food, which is for campus events, which is sustainable, which comes from sources that are sustainable, but then also fuel cell powered campus shuttles as well. So these examples can also be piloted within Canadian universities, and then sharing that knowledge as a first sort of pilot could be great before it's implemented out in the broader society.
So we're coming toward the end of our session. We are in a moment going to see this fabulous graphic that's been growing ahead of us and give our graphic artist a chance to talk us through some of the big visual images that she saw and heard in our discussion. But I first wanted to give each of you a minute for a closing remark and maybe to answer the question, can innovation in clean energy fuel the economic recovery in Canada? And I'm going to start with you, Aaron.
I think it absolutely has to. It's not a question of can it, it has to. We know that governments around the world have been investing in clean tech and innovation as a big part of their Build Back Better schemes. I think it's already part of the Government of Canada's path forward as well. You know, in budget 2021, we're investing $1.5 billion in growing the clean fuel production capacity in Canada, and $8 billion in the Strategic Innovation Fund, which is meant to drive down emissions from heavy-duty sectors, and that includes fuel switching or energy efficiency gains, and hydrogen is part of that fuel switching opportunity as well. So investments are already being made. The path forward to net zero has to be continuing support for innovation and deployment and commercialization and all of the above, and we all have to work together on our own strengths.
Inspiring thoughts. Mike, over to you. Can innovation in clean energy fuel the economic recovery in Canada? And some closing remarks.
I think so. I think maybe a slight change in perspective to those who are not believers yet, but there's so many believers now that are coming around, and the sheer growth and rate of development in the hydrogen sphere and the hydrogen economy has, like I said earlier, just swept Canada in with it. And I think that their amount of enthusiasm now is the strong driver and what we need to continue progressing this forward. And if companies are progressing in the way that we are, I think that, and from my interactions with numerous customers and partners, it looks like things are moving in the right direction at a very quick pace. And so I think that it certainly can become the economic recovery in Canada, but like Aaron said, I think it also has to be. But I'm very optimistic about this. From my perspective, things are very exciting and look great.
Thank you, Mike. Sammy, the same question to you and some closing comments.
Very much echo Mike and Aaron as well. Very optimistic about Canadian leadership and innovation and clean energy, and couldn't be prouder over the last 2 weeks being here in Europe and having conversations with scientists here in Europe about Canadian innovation. In fact, the scientists had commented about can-do nuclear technology and how Canada has demonstrated safe operation of nuclear technology. And similarly, there's hope for hydrogen as well, and Canada can take a spearheading role here, which countries around the world can look up to, can also replicate and emulate in their own strategies.
And the final panelist word to you, Sabina. You know, can you answer the debate of can innovation? It sounds like the panelists are pretty unanimous, but do you also feel that innovation and clean energy can fuel the economic recovery in Canada? And any final closing thoughts or calls to action?
Yeah, I just couldn't agree more than it's not a question of can it, but it just must. You know, we have to do things differently. I think we all know it. You know, if you look at your own life, like often the greatest change happens when there's some kind of urgent call to action. And every day in Canada, there's an urgent call to action if we just open our eyes, you know, and I know for me here in BC, it's been a really tough year, you know, from the heat dome to seeing Lytton catch on fire, and then just the fires and air quality in general in BC, and now the flooding. I mean, if it's here right now. I think we all thought we had more time. I think we're all seeing that the sort of positive feedback effects of climate change and what's happening. And it just means we have to move faster. We have to innovate more. We have to deploy all the technology solutions as quickly as we can. So I'm optimistic, but I'm also worried. I'm worried about my children. I'm worried about the future. And so it's just great to meet people across, science and engineering and government personally committed to this, because we must change. There's a lot of technology out there that can save us. Our behaviors have to, change as well. But this is the time. We're coming out of a dark period with COVID, and there's a lot of money going to be pouring in. And so let's build back better. Let's do things differently, and let's do it now.
There we go. I did it too. I turned off my camera instead of turning on my mic. But thank you, Sabina. I guess I was so action that I lost my technical device acumen. So thank you for a really important discussion, and a really strong um, uh, uh, call to action and exploration of what we need to do in Canada in order to both respond to climate change and mitigate some of the negative impacts that we've all been feeling, as well as to take advantage of economic opportunity that Canada is a leader and can build and grow industry that can be exporting around the world and solving problems, as well as contributing to good jobs here in Canada. I'd like to call at this point on our graphic artist, Kristen, if she wants to talk us through what she heard and saw from this discussion today.
Hi, thank you. I learned a lot today from all of the speakers, some really important ideas. First, starting out with understanding what the potential is in Canada for hydrogen. The industry here has already been leaders globally, and there's a real opportunity here for technology to meet the targets that are being set for 2050. Right now, about half of them are undeveloped. In Canada, there's a lot of expertise, there's competitive costing, there's lab innovation, component design, and those have been some of the real strengths that can be built off of. The opportunities here, one of the main ones is building hubs across Canada at a regional deployment, looking at local strengths and building hub and spoke kind of networks over time. There's a lot of opportunities as well. We learned in the agricultural sector, and also opportunities to kind of look at mutual shared labs, safe lab spaces that are already approved for testing and things with hydrogen. Underpinning all of this on the drawing is this blue wavy line you can see, and along this I've highlighted some different points related to policy and different opportunities there that are needed to support these opportunities and potential that were discussed. First, looking at how to deploy from home, bringing together climate policy and innovation so that they meet and line up, and really integrating the science and policy together. There's a need both for short-term supports as well as long-term, and that will really help us reach net zero. Some of the specific policy directions that were suggested is first start with an urgent call to action with specific targets and timelines that have to be met. Make funding available specifically for Canadian projects that are intended to be deployed here, setting standards, and also having pilot projects. A few of the other main points that we heard about as we moved into the question and answer period. First, understanding that this really has to be the response for recovery is looking at these technologies and bringing them forward, equipping Canadian researchers to do the work, setting procurement targets, and recognizing that we all have a role and to lead by example. So those are some of the main points I heard today, and thank you so much for the opportunity to share this.
Fabulous summary, Kristen, and I really, I think all of us would enjoy a copy of that visual that you created from our discussion today. A wonderful thing to take with us. We certainly heard about the need for vision, for government vision, for national vision, for regional vision. We heard about the idea of mandates and what different types of procurement policies could be. We also saw the huge potential from our government and university research labs through our spin-off companies to our existing industry that could be facilitated through that government strategy and that larger vision and procurement policies and mandates. A build for scale strategy could start in our universities and our research labs, leveraging Canadian clean energy research strengths and research, purposely supporting breakthrough clean energy innovation from ideation through to commercialization and production scale up, and building entrepreneurial capabilities throughout our clean energy innovation ecosystem, from government to university researchers, to scientists, and to the industry, the incumbent industry, especially in our resource sectors, that needs to take this up in innovative ways. So a really inspiring session today. Thank you to our panelists, Mike Adamski, Aaron Hoskin, Sammy Khan, and Sabina Russell. Really appreciate your time and insight today. Thank you to Kristen, our graphic recorder, and to the teams at the Canadian Science Policy Centre and at Simon Fraser University who helped to organize the panel. And a special shout out to Heather Sanders from the VPRI and to Tanya Brown from the SFU Partnership Hub for all their help in the logistics for today. So can innovation in clean energy fuel the economy recovery in Canada? We heard today that yes, it can, and most importantly, that it must. Thank you for joining us today. And we hope that you, along with these inspiring panelists, can be part of the solution and part of positioning Canada to take a leadership position in the clean energy transition.